and welcome to Chemistry Nuggets where you can polish your knowledge and clear the dust. Today's video is question number 2.54 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's take the question. If the photon of wavelength of 150 picometer strikes an atom and one of its inner bound electrons is ejected out with a velocity of 1.5 into 10 to the power 7 meter per second. Calculate the energy with which it is bound to the nucleus. Now friends, here first of all we will write whatever is given. First thing is given is the wavelength. Denoted by lambda, its value is 150 picometer, which we will convert into 150 into 10 to the power minus 12 meter, because we knew that 1 picometer is equal to 10 to the power minus 12 meter. Next thing which is given is the velocity. Velocity of the photon, which is denoted by V. Its value is given here 1.5 into 10 to the power 7 meter per second. Now friends, here they are asking the calculate the energy with which it is bound to the nucleus. So friends, before that you should understand the total energy of the photon has two parts. So energy of the photon we can mention like this, E. It is made up of two parts of energy. One thing is E naught, which is called work function, and the other thing is kinetic energy. So when an electron is bound to inside nearby the nucleus, if we put the energy, or we can say the total energy of the photon, so a part of that energy is required to break the bond with which it is passed in with the nucleus. The next part of the energy is by which the electron moves out of the nucleus, or not the nucleus, move out of the atom. So these two parts of energy together makes the total energy of the photon, which is denoted by E. Now here work function, what I am telling, work function is the energy which is required to break the bond. So here they ask us calculate the energy by which it is bound to the nucleus. So we can say that bonding energy is equal to work function E naught. So actually we need to find the work function here in this question. So we can write E naught is equal to E minus kinetic energy. Total energy of the photon minus kinetic energy of the photon, we will get the work function or the bonding energy of the photon. So let's start with finding the energy of the photon. It is hc by lambda. H is a Planck's constant. Value is 6.626 into 10 to the power minus 34 joules second, multiplied by velocity of the light. Its value 3 into 10 to the power 8 meter per second, and lambda is the wavelength given, it is 150 into 10 to the power minus 12 meter. Now what we will do, we will start calculating with 6.626 multiplied by 3. Then it divided with the 150, we will get the value here 0.1325 into 10 to the power. Now minus 12 from denominator will go up and become plus 12. Plus 12 and plus 8 become 20. Now minus 34 plus 20, it becomes minus 40, and the unit will be joule. Now next thing is we need to find the kinetic energy. Kinetic energy formula is 1 by 2 mv square, where m is the mass of the photon which is fixed and v is the velocity which is given. Now substitute the values. 1 by 2 into m value is 9.1 into 10 to the power minus 31 kg into velocity here 1.5 into 10 to the power 7 meter per second, and this whole square. Now how to do the calculation? 9.1 multiplied by 1.5 into 1.5, because 1.5 it comes under square. So 2 times 1.5, then 9.1. Now whole the value will be divided by 2 and we will get the value 10.237 into 10 to the power. Now 7 whole square, 10 to the power 7 whole square means 14. 7 plus 7 whole square means we will not multiply, we will powers are added. 10 to the power 7 into 10 to the power 7 means 7 plus 7, 14. So 14 plus 14 minus 34. Sorry, minus 31. It becomes 17, which is minus 17 joules. Now we need to put these values in this equation. E naught is equal to E minus kinetic energy. But we can see that to do subtraction, we need to make the powers equal. For energy, the power is given 10 to the power minus 14, and for kinetic energy, it is given 10 to the power minus 17. So we need to make the power equal. How to do? See, for energy, we can do shift the decimal 2 steps backward. So it will become 13.25 into 10 to the power. Now, 2 steps backward means minus 2 is added. So minus 14 minus 2, it becomes minus 16 joules. In the same way here, we'll make it 16, minus 16. So it is minus 17, it means minus 1 should be, plus 1 should be added. So plus 1 will get by shifting the decimal left hand side. 1 step. So it is 1.0237 into 10 to the power minus 17 plus 1, it is minus 16 joules. Now the powers are equal, we can do the subtraction. Before that, we can't be able to do the subtraction. Now start the subtraction. So it is bonding energy, which is equal to work function. Here also it is E minus kinetic energy. E value we get 13.252 into 10 to the power minus 16, minus kinetic energy is 1.023 into 10 to the power minus 16. So after doing subtraction, we will get the value 12.227 into 10 to the power minus 16. Now, unit is joule. Now, this is our bonding energy in terms of joule. Now, we can convert this into electron volt also. For this, we need to know 1 electron volt is equal to 1.602 into 10 to the power minus 19 joules. So we can write it, divide it, this joule into electron volt. So 12.227 into 10 to the power minus 16 divided by 1.602 into 10 to the power minus 19. So we will get, after doing division, we will get the value 7.6 into 10 to the power. Now minus 19 will go up and become plus 19. Plus 19 minus 16 becomes plus 3. And the unit will be electron volt. So again, this is the bonding energy. So this is also the correct answer and this is also the correct answer. We can write any answer depend on the time. If we have time, we can go till electron volt. If we don't have time in the exam, we can stop till joule. So friends, keep on watching the video. Do like, share and subscribe the channel. Till then, thank you.